In this video we're going to look at the intersection of two planes. What I'd like you to do to start with is take yourself two pieces of paper and just to see how they might meet. So pause the video now and try that. Welcome back. So if you've made the two planes meet, then they should intersect like this. Okay, so there we have two planes that meet, and the interesting thing about how they meet there is that they meet at a line. So if we were trying to find how they met, we would have to define the line where they meet. And that's pretty obvious. If you look around the room and look at how two walls will meet each other, they will meet at a line like that. Now then, you might be able to make the bits of paper not meet. And if that's the case, then your pieces of paper look like that, in which case they must both be parallel. There's the final case of two planes interacting with each other, and they might be what we call coincident planes. In other words, where one plane is on top of the other. So the three possibilities that we've got are that two planes can meet, they can intersect at a line, they can be parallel, therefore there will be no intersection, or they could be coincident, they're actually the same plane. Now then, before we consider that for the minute, I want to have a look at the equation of a plane in Cartesian form. So here's a plane, and the equation of this plane is given there. X plus 3y plus z is equal to 5. And what I'm going to do here is just change this value to a different one, and I want you to look at what happens to the graph. Did you notice what happened? Let's try that again. Let's change it to something else. Let's try -1. Look at the graph. Okay, and actually I can make that change to any value I like. I'm going to put a parameter in there, d, and what I can do is change that value of d, move it up and down. Okay, so the value of d there is 5, so that's the equation. X plus 3y plus z is equal to 5, and we can see what happens to the plane. Each of the planes here, you notice, are parallel to each other, but it's just the position that's changing. And that's a clue to us how we will answer these questions. So let's just consider that equation for a minute. What we looked at there was this equation, and we changed the value at the end here and noticed that the planes were always parallel. And there's a good reason for that when we consider the other form. The normal form of the equation of a plane, and it's the coefficients of the x, y and z term, 1, 3 and 1, that are going to give us the direction of the normal of the plane. So if this part of the equation never changes, the direction of the normal changes, therefore it will always be a parallel plane. And you can say even more than that, of course, because if you consider an equation like this one here, 2x plus 6y plus 2z is equal to 30, then that's going to be parallel too. The direction of that plane, 2, 6, 2, the direction of the normal, is going to be a multiple of 1, 3, 1, therefore it's going to be parallel. So that's going to be a clue to us in answering these parts here. So here's a question. We're going to have a look at these two planes here. Now the first thing I want to do is to work out whether they are actually parallel to one another. So the direction of the first one and the direction of the second one, are they the same? Are they parallel? Well, the normal to the first one is 1, 3, 1. It's the same one we just had there. And the normal to this one is 2, minus 1, minus 1. Is this a multiple of that? No, it's not. There's no value of k that we could put in there to make the two vectors the same. Therefore, they are not parallel. Now then, if they're not parallel, that means that they must meet. So, as we said before, if they meet, two planes are going to meet at a line. And what we've got to do here is find the equation of the line. Now your graphic calculator can cope with that quite well. So with if you've got a TI-84 series calculator, then it will actually, if you come to the apps, you might have Polysmlt or Polysmlt 2 in there, it will solve simultaneous equations, and that's basically what we've got here. So if I come down to equation finder, now then we've got two equations, but we've got three unknowns. Click on next, and we'll just put them in here. Now this is just a system for a matrix, and all you've got to do is put the coefficients in there of the equation, 1, 3, 1, and then 5 here, and for the second one 2, minus 1, minus 1, and 1. And the calculator will solve that for us if we press this button here. So that's a rather strange solution, isn't it? Now the x1, x2 and x3 are x, y and z coordinates there. So we've got a solution of 8 over 7 plus 2 over 7 x3, so that's z. And then I've got y is equal to 9 over 7 minus 3 over 7 x3, which is z. And then I've got z is equal to z. So what we've got there is the parametric form, really, of a line, equation of a line. If we replace the z value there by a parameter, for example lambda, then that might look a little bit more familiar to us. And this is what we want to find. So if we're lucky enough to be able to use our calculator, then why not just use your calculator for that? But quite often you're asked to do this without a calculator. So let's try and find it without the calculator. So if you remember there, we had all the x, the y and the z all in terms of a different parameter, or all in terms of z to start with. And that's our clue for doing this. So what I'm going to do here is I'm going to try and eliminate x from this pair of equations so that I can get z in terms of y, and then combine them again in a different way and eliminate y so that I can get z in terms of x. So let's eliminate x first of all. So we'll times that one by 2. So I've now got the same amount of x's. I can just subtract these equations, and then I can rewrite that z is equal to minus 7y plus 9 all over 3. Right, let's do that again. This time I'm trying to eliminate y, so let's times this one by 3. So I've now got, let's just put a line through that so I don't confuse myself. These two, I've got the same numbers of y, so I just need to add here because that's negative. So 7x minus 2z equals 8. So z is equal to . So what that means is that 7x over 2 minus 4 is z, which is the same as minus 7y plus 9 over 3, which is z. So what we've got there is the Cartesian form of a straight line in 3 dimensions. And that's exactly the same equation that we found with the calculator, although the calculator had it in a slightly different format, so it had x in terms of z, which is quite an unusual way of writing it, unless we put it in the parametric form there. Now we could just show very quickly that those two things are the same. So just to reiterate, this is our answer, and this is absolutely fine as an answer. It's the Cartesian equation of a straight line, but it just seems a little bit unsatisfactory to say those two equations, the one we've got here and the one we've got with the calculator, are exactly the same. So let's just briefly show that. So there we have a method for checking and considering two planes. Just to remind you that they may intersect, and if they do so, they intersect at a line, and this is the method that we use for that, combining the equations in two different ways to eliminate one of the variables, eliminate y here, sorry, x here and y there, and so that we can write a Cartesian equation of the straight line. But there may be instances where the lines are parallel, or they may be coincident. Well, if they're coincident, they're parallel as well, and if that's the case, then the directions of the two lines will be the same. And it's very, very simple to show that they are the same or not.